Recording started.
Okay, so guys, we're just going to start the recording now and start the competition. And so I'll also send out that video later on to show people the pistol shrimp video, to people who weren't able to see it. Yeah, chances are you wouldn't run into one of those pistol shrimp most of the time, so I wouldn't be too concerned. But okay, so we're going to get into this stuff relating to light. And okay, I see somebody just joined us. That's Mazda Panda. So we now have two. Oh, first of all, welcome Mazda Panda. And we just played a video, and I will later on I will share it with the rest of the class for anyone who missed it at the beginning. So we now have two land creatures, two sea creatures. So maybe what I'll do is I'll get the mystery person to do half the time for sea creatures and half the time for land creatures. We're going to have 9 questions, so maybe the mystery person can answer, let's say, the first 4 for land and the next 4 for sea or something like that. Okay? So the first part here talks about telescopes, that they perform 2 important jobs for us. They collect light and they magnify light. Okay, and it's not only telescopes that have those 2 important jobs. Other important instruments like microscopes, excuse me, they do the same thing. So any kind of lens or mirror is going to carry out these 2 same jobs. Okay? You have new mail. Kind of device like a telescope. So I'm just going to check and see if somebody's coming on. Okay, so on to the next page. So a microscope uses 2 lenses to magnify the light. It uses the ocular lens and the objective lens. And I just want to briefly go over some stuff having to do with why light is more intense if objects are closer to us. If you guys look at these here, these are light rays coming to our eyes. And as you can see, the closer you are to an object, the more the light rays are concentrated, the less spread out they are. You have new mail. Okay, so you can see that. Just check here. So you can see that, right, that they're less spread out here. And so you have a larger number of light rays falling on the eyes in this situation here, right? When an object is close to us, they're spreading out a lot more when the object's further away. So do you guys remember we talked about 3 different materials that light can pass through and the names of each of those? If light passes all the way through a material, it's called a transparent material. If it's only part way through, it's translucent. And if no light at all passes through, it's opaque. So I don't know if you guys can think of any examples of any of those, anything that's translucent or opaque, or can you guys think of something like that? Translucent, something in your room that's translucent, or... Sorry, I'm just going to, while you guys are thinking of that, I'm just going to see if somebody else is going to be signing in. Somebody else who's on. Okay, just give me a sec here. Sorry about that, guys. There was somebody else who might be coming in. Okay, so you're saying tissue paper, and would that be transparent or translucent? Yeah, I would say that's translucent, right? Some of the light comes through, but it doesn't all come through. All right, so I don't know if you guys are interested in photography, but in photography, sometimes you use a wide-angle lens. And if you use a wide-angle lens, you can see a scene like this. Like you see a whole bunch of it all at once, because it's like a wide angle, right? It's a really big angle. Whereas if it's a zoom lens, you're zooming in on just part of it. And especially if you're doing like portrait photography, and you want to get, you know, a really good moment, just capture a moment, then a picture like that would be really good. Okay, so remember the difference, guys, between a wide-angle lens and a zoom lens, and another name for a zoom lens is just a telephoto lens. Okay, so we're going to get into some questions now. Now, these ones won't be part of the competition exactly, but you can still answer these ones just by typing in your answer here. But again, don't feel you need to for these ones, but for the other ones you'll be moving something around to show what your answer is. So what do you guys think? What are the 2 jobs performed by a telescope? You're saying magnify images and collect light? All right. Anybody else have any other ideas? And Mazda Panda saying your hand is translucent. Yeah, I guess light can pass through your hand. That's true, isn't it? Because sometimes you have light behind your hand and it turns red, doesn't it? So, okay. So you guys are saying that the answer for this one is D, that images are magnified and light is collected. You guys are right. Good stuff. So if that would have been part of the competition, you guys all would have got a point for that. Good stuff. Now what do you guys think is another name for a zoom lens, which lets you get in close to an object? Is it a normal lens, wide-angle lens, telephoto lens, long distance? Okay. Telephoto? Does everybody else think the same thing? Telephoto? All right. And you guys are all right. Good stuff. Okay, so now is going to be the real stuff, guys. Now, at this point, you guys can move your part, your tag. Don't move it yet, please. But I just want to make sure and see who we've got on each team. We've got these two on this team. I'm just going to move away the ones that we don't have. We don't have Majestic Horse here. And, okay, Ariel, welcome, first of all. I guess we know who you are. So, Ariel, would you like to be, I just got to see who we've got and who we don't have here. So we've got Squiggly Squid. Okay, sorry for I think we've only got one sea creature. Okay, Mazda Panda. There's Mazda Panda. Sorry about that. Okay, so how about Ariel, if you are the mystery sea creature, and the other person whose name says mystery, if you can be the mystery land creature. This should say mystery LC, but mystery person, if you could be the this person here, and then Ariel, if you could be this person here. Then we're tied, we've got 3-3. Okay? So at this point, if you guys want to move your name tag to the letter, okay, so move it to A, B, C, or D, and then we'll see which side wins the point. So the question says, the reason why lights which are close to you appear more intense than lights which are further away. What do you think the answer would be? Move to the answer that you think is the correct one. Okay, you're not able to move. Now what you need to do to move it is to click on this arrow. See that arrow button? If you click on that, oh, okay, I'm sorry, I need to give you guys the ability to do this. Just a sec. Sorry about that, guys. Okay, try it now. Are you able to move your tag now? Good stuff. Okay. Looks like most people are saying C. Is mystery sea creature on C as well? Okay. So you guys are all right. So sea creatures and land creatures. Ah. You didn't guess. Okay, so Panda Mazda, you're guessing? Okay, I'm not sure who won on that. I'm going to give it 50-50. I'm going to say that both teams won. Okay, so we'll go on to the next question. So does that make sense to you guys then? The reason why light appears more intense is because the closer the light is to you, the more light rays are striking your eyes. Does that make sense? Whereas if light is further away, if an object's further away, the light coming from the object has had time to spread out, right? Okay. All right, let's go on to the next one. So again, you can just answer this one. This one doesn't count for... No, it's not how quick you get the answer. I'd like to give you a little bit of time just so everyone has a chance to answer it. Okay, so this one isn't for points. That's right. You only get it if whichever team has the most getting the right answer, that team gets the point. Okay? So next question. A substance in which no light can pass through is called... We've got one answer there. Okay. We've got some more. Okay. It should be C. It's C is an opaque object is an object in which no light can pass through, right? And if some light, it's translucent, and if all light, it's transparent. Okay. All right. We just had Majestic Horse join us. Welcome, Majestic Horse. Good to have you. And so now our teams are a little bit out of balance, but that's no problem. No problems at all. Majestic Horse, if you wouldn't mind, the next time we have a question, if you could please, the next 4 questions, if you could play for the sea creatures, because we've got 8 left. If you could play for the sea creatures for the next 4, and then the last 4 questions that have where you can actually move around your name tag on the screen, if you could play for the land creatures, okay? And that way everything will be even by the time we're done. Okay, right on. No guessing, guys. No guessing till the end. Then we'll find out who's who, okay? We'll just keep it a mystery for now. Okay, so we're going to talk about the pupils of our eyes. The pupils of our eyes are like an aperture of a camera, right? The pupil of our eye is a hole, and the hole will open and close depending on how much light we want to let in. And so this aperture that's on a camera is also a hole, and it also opens and closes to let light in. Okay, so remember the pupil's like an aperture, and you know that if you go into a really bright room, your pupil is going to go like this, right? I'm sorry, it's going to go like this, rather, because it doesn't want to let in very much light. There's too much light, and so it wants to close down. But if you go into a dark room, you're going to have a dilated pupil. Okay? So it's going to be open really wide to try to get as much light as possible. So a dilated pupil is one that's really wide. A constricted pupil is one that's really narrow. Okay? And remember which condition you're going to have which type of pupil. All right, so something like an owl, which is a nocturnal creature, is going to have very large pupils, right? Because it lives at nighttime, and so it wants to have a lot of light coming in. Okay, now there's 2 different things called photoreceptors that are found in the retinas of your eyes, and they do different jobs. Rods are one type, and they detect how bright the light is. So whether the light's really bright or really dim, that's what rods tell you. Whereas cones tell you how sharp an image is and also let you see colors. Okay, so that's the difference between light or rods and cones. So I'm just reading what Panda Mazda said. It's constricted, it strikes how much light goes in. Yeah. So okay, can you guys give me a check mark if you can still hear me? I'm not sure if it's just Mavis. Okay. Hopefully the sound stays okay, and if it for some reason does have a lot of problems, you might have to just watch the recording, but I'm really hoping it doesn't do that. Okay, so guys, we talked about rods and cones. Let's go on to the next page and have a question on it. This one won't be for points. The only one that are for points is when you can move around your name tag, right? Okay, so can you guys choose the pair which correctly shows the part of the eye which has a similar job to the part of the camera? Which part do you think that is? Okay, we've got some people saying C, some people saying A, B. Okay, so we got a whole bunch of different answers here. Does somebody want to give a reason for the answer they chose? If you feel comfortable, you don't have to. But if somebody would like to give the reason, then we can have a little bit of discussion. Okay, cameras do have lenses, that's true. Now what's the job of the pupil again? You guys remember what its job is? Yeah, it lets in the amount of light that you need. Okay. and so it opens and closes, right? And it's actually the aperture. I'll just bring you back there. So the aperture again is like a hole, and it closes or opens to let in the correct amount of light. Okay? So the pupil of your eye is like an aperture, so it should be answer A. Okay? So we'll go on to the next one. Okay, time for the competition again. Now I think the only person who isn't here is Social Sunfish. And so what you guys can do then is everybody else, and I have to remember to myself, Majestic Horse, we said you were going to be a sea creature in the beginning, right? So we'll remember you're one of the purple guys. Good. Okay, so if you could choose the right answer here, choose the conditions which match which state or size your pupils will be in. Okay, so match the type of light with the type of pupils you'll have, whether they're constricted or dilated, and then we'll discuss the answer in just a sec. Okay. Now, Panda Mazda, have you chosen already? Okay, so you're saying it's unknown. All right. So I'm just going to separate you guys for a sec. So if you guys could just let me move them for a sec here, okay? So Majestic Horse, you're a sea creature, right? Okay. So it looks like the sea creatures won that one because it is the right answer. In dim light, you're going to have dilated pupils, right? Remember, dilated is really big. So if it's in dim light where it's really dark, you want to open up your pupils as wide as you can, so that way they're going to let as much light in as possible. Okay? Does that make sense, guys, now, why it's B? And please just stop me at any point if any of them doesn't make sense. Yeah, you can take notes, but also remember you can look at the recording as well, right? Okay, good stuff, guys. On to the next one. Nocturnal creatures have, what do you think this would be? Again, this one's not for points. What type of pupils do nocturnal creatures have? Large pupils and more rods than cones. Does that make sense to everybody? They're going to have large pupils and more rods than cones? That's right, because they want to have large pupils to let in a lot of light, and rods are really sensitive to how light or dark it is, so they're going to have more rods than cones. Good stuff. You guys are really catching on to this. Right on. Okay, so next question. Which structures are responsible for black and white and color vision respectively? And funny joke there, Majestic Horse, I like that. Okay, so first one listed is going to be which ones are black and white, and second is going to be color. So you guys are telling me it's going to be answer B. Okay, any other ideas? I'll give you a hint. Both of them are photoreceptors. So which two are photoreceptors? Is it retina and the optic nerve? Are those both photoreceptors? Rods and optic nerve. Okay, a lot of people are saying answer C, and that's the right one, because black and white is going to be rods, like how dim it is, and cones is going to be color vision, or also how sharp it is. Good stuff. Okay, now this stuff here is going to go into a little bit about different types of lenses. We've got concave and convex lenses. Just remember the cave part of the word concave. It looks like a cave, right? This part here. So that helps you remember what a concave lens looks like. And you can see that it spreads out the light, doesn't it? A concave lens, whereas a convex lens is going to focus the light on one point. All right. And remember this, guys, the farther an object is from this focal point, okay, again, the place it focuses it is the focal point, the farther an object is, the smaller it's going to be. Okay? Now, there's some other things we need to remember here. Remember that our eyes are shaped like a convex lens, right? You guys all have eyes that are shaped like this, right? I don't think any of your eyes are shaped like this. Am I right? Well, lost my pointer. This here. So in the same way, our eyes are going to do the same thing, right? They're a convex lens. They're going to focus something on this one point. The place they focus it is the retina of your eye, and that's the place those photoreceptors, like the rods and cones, are found in is the retina. Okay, so our eyes are going to change their shape. So you guys ever notice that when you see something far away, you kind of squint your eyes? And when you're squinting them, you're changing their shape. And that gives them a different place where they're going to focus this focal point. Okay? So our eyes change their shape. And you guys probably have heard this before. Someone who's nearsighted can see things that are near, but they find it hard to see things that are far away. And someone who's farsighted can see things that are far, but can't see things very well that are close up. Are any of you guys farsighted or nearsighted? Okay. And fortunately, if you have glasses, that can fix that, hey? You guys might have heard of the Hubble Space Telescope that takes these really cool pictures in space. There was one point they had a problem with it. Yeah, I'm getting a lot of email. And they actually had to fix it. They basically had to put glasses on the Hubble Space Telescope, which is pretty amazing. And after they did that, it worked again, which was very cool. Okay, guys, so now we've got another one for points. So, again, I'll take away the one that is for social sunfish, and I think everybody else was here, right? Okay, so we got a few A's, few B's. Okay, so we've got mostly B's. Are you guys all finished choosing? Okay. All right. So the answer is the focal point is focused using a convex lens. That's right. Okay. So let's see who gets the point on this one. Now, Majestic Horse, you were a sea creature, right? Okay. And okay, so this is, sorry guys, I'm getting confused here. These ones are the land creatures, right? Majestic Horse, you're also a sea creature. Okay, so it looks like the sea creatures get that one. Okay, and remember, please remember, Majestic Horse, after you do the first 4 for the sea creatures, then please do them for the land creatures, okay? So that makes sense, guys? The focal point is a place where light is focused. That's using a convex lens. Okay? You guys remember the diagram that shows the convex lens and how it will focus? Sorry about the phone there, guys. Between my email and the phone. Sometimes I remember to take the phone away, but sometimes I forget. All right. I hope it stops soon. Actually, it's one of my students, but I'll have to get my wife to take it for me. Okay, so which of the following is not true about our eyes? So if you guys just want to choose whichever one you think is not true. Okay, does anybody else want to take a guess? We've got a D. Anybody else? Concave? That's right, because remember, our eyes are convex. And if they were concave, they would spread out the light, and we want them to focus the light, right? Good stuff. Okay. Okay. All right, that's probably good. So guys, nearsighted people have trouble seeing objects that are close to them. This one's just true or false. Okay, this one's false, right? They can see objects that are close to them. I might have to... Okay. Actually. Okay, so guys, just take it easy on that, okay? So nearsighted people can see things that are near. They have trouble seeing things far away, right? Okay. So here we got a picture of the sun, right? And we got all these rays coming from the sun. So as we know, when we think about the sun, if you think about the way you drew a sun when you were younger, right? You would draw it as if it was like all these little lines coming off it. And so light waves travel in all directions, right? And both light waves and water waves are similar, that they travel in all directions. If you throw a pebble in the pond, that's going to travel in all directions too, right? And you guys also know that light rays travel from an object to our eyes. So originally they come from, say, the sun, or maybe they come from a light, and then they go bounce off the object and then bounce off the object to our eyes, right? They always travel from the object to our eyes. So remember, they travel in all directions. Okay, so we're ready for our next question here. So when studying water waves and light waves, you learned that. What do you think the answer is for this one? Okay, so the answer for this one should be B. All right, so let's see who got this one.
You have new mail.
I believe it's the sea creatures got this one. Okay, so does that make sense, guys? Both light waves and water waves are forms of energy, and they travel out in all directions. Okay? All right, so moving on to the next question. So both cameras in our eyes, when they make a record of something, when they make an image of something, they record that image upside down, right? But in our brains, our brains can actually figure it out and put it right side up. So remember, there's a difference between a real image and a virtual image. If you have something called a real image, it can be produced on a screen or a piece of paper, while a virtual image cannot be produced on a screen. Okay, so now we're going to talk about something that has to do with kind of photography. You guys like digital photography? Well, whether you're talking about photography or television, you've got these little dots on the screen, right? All these tons of dots. Those things are called pixels, and many thousands of those little dots make up a picture, right? Now, depending on how many dots you have in a certain amount of area, this is an area, right? I'm talking length times width, it gives you a certain area. So if you've got a low quality picture, that's what we call a low resolution picture, and it has only a few pictures per square centimeter. But I'll show you on the next screen. This is a high quality or a high resolution picture. You've got many pixels per square centimeter. And if you look at these two pictures, you can see that this one's not as good quality as this one, right? So again, low resolution, few pixels per square centimeter. High resolution, many pixels per square centimeter. Okay, so now we're just going to talk about insect eyes, right? It looks kind of spooky. You can see they've got a concave lens, right? And so these things have these little dots, and these things are called onomatopoeia. I don't know if you guys remember that. But the more of those they have, the better eyes they have.
You have new mail.
So just like a picture that has high resolution, it's got many, many dots. These pictures, or sorry, these insects, such as dragonflies, have a whole bunch of these little things called onomatopoeia, and the more they have, the better their eyes are. Okay? So, on to the next page. I think we're done with this one. Okay, so what do you guys think? What is true of a high-quality image? Somebody want to take a guess on that? You guys are right. I've been getting lots of email. Okay, so we got a whole bunch of B's. All right. So maybe just one guess, okay, guys? So we got some B's and some D's. All right. So the answer is actually D. All of these things are correct. Because if it's a high-quality image, I said high quality means high resolution. That also means there's a lot of pixels per square centimeter. All right, take it easy on those B's there, please. Also, if it's a high-quality image, it's clear and easy to see, right? Okay, so all of the above are true about a high-quality image. So let's go on to the next page. All right, so you guys remember we looked at an insect eye. Dragonflies have excellent vision because their eyes, what do you think? Yeah, your bees are buzzing, aren't they? All this talk about insect eyes, you got buzzing bees. Okay, so some people are saying B, some people are saying D. Any other answers? Okay. All right, well, the answer should be B. Because remember, they have a convex shape. I'll just draw it for you guys again, just a sec, if I can get my little drawing. Their eyes are like that, and that's convex, right? Remember, if we have a convex lens, it looks like that, right? I know my drawing's not so good. If it's concave, it looks like a cave on the outside, right? So their eyes look more like this, so it's a convex lens, and remember, they have many of those ommatidia, or however you say it. Okay? So convex shape, many ommatidia, that's what insect eyes are like. Okay? Does that make sense, guys? Okay, so we're going to talk now about, this is called the electromagnetic spectrum, and these are all electromagnetic waves. Look at the different waves we have here, guys, all different waves, right? We've got X-rays, those are really high energy waves. They're short waves. These are really long waves, these ones here, all right? There's this tiny little bit out of all those different waves, which are the visible waves. So only a tiny fraction of all the waves that are out there are ones that you can see. Okay, now let's look at which waves are the shortest of any waves. The shortest of all the waves are gamma rays, but the shortest of the light rays are violet rays. Now, how do you tell the difference? If you want to just remember that Violet was a really energetic girl, just remember that. That'll help you remember what the shortest of the visible waves are, because remember that short waves are really energetic waves. Okay? So the longest of the waves, can you guys tell me which are the longest waves of all the waves that you see on the diagram? Okay, so as far as light waves, the longest ones are the red waves. How about as far as all the waves that are there? Can you guys tell me which are the longest of all the waves? Okay, this is what I'm thinking of, guys. It's going to be these AM radio waves, okay? So again, I'm talking about, some of these times I'm talking about which are the longest visible waves, but also which are the longest light waves, and then we also talked about which are the longest of, or shortest of all the waves and the shortest light waves. Okay, so try to remember that, because we're going to have some questions coming up on which waves are short and which waves are long, and remember which colors are which, okay? All right, so short waves carry a lot of energy and they're more dangerous. So if you guys look, there's these UV light waves. Where do those guys come from? You guys remember where UV waves come from? They come from the sun, you're right. And so you can see they've got a little bit more energy than all these light waves that are packed in here, right? And because of that, they're more dangerous, and so we have to put sunscreen on, right? So short waves like UV rays carry a lot of energy. And long waves carry less energy, and so that's why all these radio waves that are out there going around, they don't harm us at all. Okay, next question, guys. And I don't know, Majestic Horse, is it your chance now to be a land animal, or are you still a sea creature? Oh, this is the last one. Okay. Then you get to be a trader. No, just kidding. Okay, so which of the following is correct as far as the longest light waves and the longest of any waves? So first we want to choose long light wave and then longest of any waves. Okay, so it looks like, Squiggly Squid, are you on answer? Sorry guys, I can't tell where everyone is. As far as I can see, everyone's on D. Is that right? Is there anyone who's not on D? Because I can't seem to see anything else. Okay. Well, answer D is right. So you guys both get the point. Because the longest light wave is going to be the red, and the longest of any wave is radio. So I'll give you guys the clapping hand. Can I do that? Oh.
You have new mail.
Okay, I did it wrong. There we go. Smiley. Now can I turn it off? Okay. All right. So on to the next page. Which of the following waves carry a lot of energy and therefore can damage our skin? C. And the C's have it. Good stuff. Right on. Okay, next question. Visible light makes up a large part of the electromagnetic spectrum. True or false? It's false. Yep, they only make up a small part, remember? Okay, the electromagnetic spectrum, is that what you were wondering about, Ariel? That's all those different waves. That's what the electromagnetic spectrum is. You got kicked off, Squiggly Squid? Okay, good to have you back. Okay, so guys, when we looked at waves, the amplitude of a wave is between this part, which is called the resting point, so the dotted line, and the height of the wave. That's the amplitude of the wave. Okay? All right, you got a question, Mazda? Okay, please only press that if you have a question, okay? So the amplitude is between the resting point and the height. So in other words, the amplitude is how high the wave is, right? So it's between the resting point and the height. The frequency is like the speed of the wave. So it's how many wavelengths pass through in a certain point in time. So the wavelengths per second, that's the frequency. Okay. So Mazda, you were getting a bit of lag, like in the sound, is that what you meant? Okay, no worries. Okay, so you guys remember what the difference between amplitude and frequency is? The amplitude is the height of the wave, and the frequency is the speed of the wave, right? All right, so I think this is the first chance for Majestic Horse to be a land creature, no longer a seahorse. So what do you guys think? Which of the following is the frequency? And I'll play the Jeopardy music. Do 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 do. Do 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 do. Okay, drum roll. All right, so it looks like that's one for the land creatures. The answer is B. Oh, no, it's not. I'm sorry. The answer is C. That's sea creatures. Squiggly Squid got it right. It should be the sea creatures. Sorry about that. Because the frequency is like the speed of the wave, right? It's the number of waves per unit of time. Does that make sense still, guys? At this point? Number of waves per unit of time? Okay, so that's what the frequency is. It's like the speed of the wave. How many waves you have passing by in a certain point in time. Okay, so what do you guys think? What's the amplitude of a wave? It's from where to where? Anybody want to take a guess on this one? From the rest to the crest? That's right. It should actually be answer A, guys. It's from the rest to the crest. The resting point of the wave is like that. This should be a dotted line, right? And then the rest of the wave went like, oh, sorry, gotta get the right thing. The rest of the wave went like that. So it's from the resting point to the crest, which is the top of the wave. Okay? You hate wavelengths. How can it be? Okay, so we're just going to talk about flashlights, right? Now, flashlights are a luminous object. And remember, a luminous object produces its own light. So I've got a question for you guys here. This isn't even on the screen. Do you guys think that the moon is a luminous object? Would you say the moon is a luminous object? No, that's right. It doesn't produce its own light. It reflects light from the sun. So it's a non-luminous object, right? Okay, so I'm going to explain to you guys what this thing on the screen is about. Okay, you can see that a flashlight uses a concave mirror. And so the light starts from one point and it goes in all directions, right? But how would you describe the light rays that bounce off the mirror? How would you describe these? You guys have probably come across this name in math. How would you describe what these rays look like? They're parallel. Good. That's right. So whenever light in flashlight bounces off that concave mirror, it goes parallel, right? And that's why you can shed like a beam of light using a flashlight. Okay? So remember that. Concave mirror and parallel light rays. So does that diagram make a little more sense to you guys now? Good stuff. You guys are awesome. Okay, next question. Because a flashlight produces its own light, it is known as a, what kind of object? Luminous. That's right. Instead of non-luminous. Good stuff. Okay, we are up for another question. Good stuff. Mazda Panza. Okay. What do you think, guys? When light leaves the flashlight, which uses a concave mirror, light rays will... Okay, I'm just trying to figure out where Panda Mazda, are you on there? Can't see you. Okay, now I see you. Okay, so, Squiggly Squid, is Squiggly Squid with us still? Okay, so everyone's going for answer A, am I right? Or Squiggly Squid is going for C? Okay, well, I'm going to give it to the land creatures then. When light leaves the flashlight, which uses a concave mirror, light rays will run parallel to one another. Okay? So we've only got a few more to go, guys. Do you guys remember this business about law of reflection? It says the angle of incidence is equal to the angle of reflection. So what does that mean? Okay. Well, it's like if you're bouncing a ball off a wall. This is like the ball that's bouncing. That's the light that hits an object. And then this is the bounce that comes off it. That's the angle of reflection. All right, so always remember that. The law of reflection, the angle of incidence equals the angle of reflection. These are the same angle, right? Now this is called a regular reflection. If light goes off something that's shiny and smooth, then the light rays go parallel to each other. But if the light rays go off something that's rough, they go all over the place. They don't run parallel. Okay, so only light that's going off a smooth, shiny surface is a regular reflection, and then the light rays are going to be bouncing off parallel. Okay, so which of the following is true, guys? C. Light bounces off a mirror at the same angle that it strikes it. Good stuff. How about this question? Which of the following is not true of regular reflections? That's right. It says light rays spread out in all directions, and that is not true. The other things are true. Good stuff. Okay, here's a check on some different terms we've looked at before. You guys remember refraction is the bending of light rays, reflection is the bouncing of light rays, dispersion is the spreading out of light rays, and frequency is the speed of light rays. Now, if you have light that's traveling through the air, and then that light comes into the water, look what happens. The light rays are slowed down, so the angle changes, right? So what happens is the water is more dense or thick than air, and that's why it happens. And water has more particles in it, and so the speed of light in water is less than the speed of light in air. Okay, so on to the next page.
You have new mail.
Okay, so next question says, which of the following is not true? So we're looking at some different, okay, so we're looking at some different definitions here, guys. Sorry, I just checked my email there. That's why I was kind of out of it for a sec. Okay, so we've got some A's. We've got some B's. Now, I just wanted to ask, Mystery SC, have you chosen? And Mavis, have you chosen? Okay. So, it looks like, okay, I'm just gonna base it on who's here at this point. So it looks like it's a tie. I'm going to give you guys both the point. It should be D. Frequency is the length of a light ray, and that's not true, right? Because frequency should be the speed of a light ray, or a light wave. Okay, on to the next one. Which of the following is a property of light? What do you guys think? Okay, whoever did the pointer there has got it right. All of the above. So light can be reflected, light can be refracted, and light's a form of energy. All of those are true. Good stuff. Okay, so what do you think about this, guys? Have you ever taken a pencil and put it in water and then noticed that it looks kind of rubbery, right? The reason why it's bent, why do you think it's bent? Which one of those gives the reason why it's bent? It's actually the refraction of
Goodbye.
Right? It's going to be answer A. It's the bending of light. That's what causes it to look bent. Okay? Because the light rays are not going to travel as quickly in the water as they do in the air. Okay, guys, so just take it easy on those pointers and stuff, because we got to run through this stuff, okay? So just, if you could please not be putting them on the screen, okay? So remember that white light is made up of all different colors of light mixed together, so it's not black light. And the proof is if you take some white light and put it through a prism, you're going to get all those colors back again, right? Remember also, guys, the three primary colors of light are red, blue, and green. I know normally we think red, blue, and yellow, but that's but that's painting colors. That's not light colors. Okay, so old yeller. Okay, so try this one, guys. What's the three primary colors of light? Okay, remember not to give the answer, only on the screen, okay, please? So, it looks to me, I'm not sure, has everyone chosen? Okay, it looks to me like the land creatures will get that one. Three primary colors of light are red, blue, and green. Good stuff. Okay, what do you think for this one? What kind of light passes through a prism to produce the color of a rainbow? White light. You're right. And look at that. We're done. Looks like all that stuff's just illuminated advertising. Okay, awesome. Guys, we finished up just in time. I think the next crew is coming up. So please practice these questions again, like I always say on the emails, right? Practice them over again till you can get them all on your own. Okay, just hold off with the check mark till we just finish up, okay? So finish up with these guys. Okay, so finish trying all these before the test, guys, and then make sure you can get them all on your own, and then you should do well. So if you guys want to let, the test is on Monday. So, okay, well that's all right. We can talk about when you can write it if you need an extension on it. But yeah, the test is on Monday. Again, please study hard. You know, this is the second last test of the year. I want you guys to do well. So I'm going to stop the recording at this point.